Off on everybody. Could you flip the lights, dim them, so make them opposite of each other, and then there you go. That light's on. All right. Here we go. Going through kind of quickly. Yeah, I can give you a mark. Marking you. Yep. All right. In the diagram, AB is that, MC, okay? I know I had this. So you're doing segment addition, stuff like that. Is there any questions on problem number 1 up there? And I know there's all the answers that are on the back, so make sure you understand why the answers come to. Or is there anything on number 1 you need me to do? Yeah.
Can you do A?
A? Yeah. A, B, C, D. Okay, so they want us to figure out BC. And they tell us that AB is 8. And they tell us AC is 11. I have enough information to do that because I know that 11 minus 8 has to be 3. That's the segment subtraction. Anything else on problem number 1 that you need me to go over? All right? Yeah. Good. B? BD. So they want us to find BD now. So with this information, I know this right here is 3 because we already solved it here. And then they also tell us that AD, so A to D is 17. So if they want us to do B to D, I guess what I could do is let's figure out what this is. So I'm going to take the whole minus the part, so I get 6. So this is going to be 6 now. And then from B to D is going to be the 3 and the 6, which will give you the 9. Are we all right? Yeah.
Okay, so can you see?
Yep. AC. So A to C, they want this right here. So with the information we know, they gave us this. We had found this on the next one. So from A to C, it has to be 11. The AB was given, and we found that BC was 3 because, and they also gave us this. A to C was 11 as a given. Right? Yep. I don't know why that was kind of funny. They gave it was given, and then they said find it. Problem number 2 is C the midpoint of AD. Is C the midpoint of AD? AD is 17, so the middle of 17 would be like 8.5. So no, because C to D is only 6. It would have to be 8.5 in order to be the midpoint. Number 3. 3, A, B, or C. Any of those you want me to do? Yeah? 3A. Okay. Assume that point S is between R and T. Okay. R, T. And they want you to say S is somewhere in here. So they tell us that RS, that distance there, is 2x plus 10. And they also tell us that segment ST is x minus 4. And they told us that RT, the whole distance, is 21. And what do they want us to find? Assume that point ST, okay, use the below to set up. So they want us just to start identifying what the segment pieces are that are unknown. So basically, we already know RT, so we want to find this and this. And I'm using segment addition. I can do this. Is that okay? Combine the x's, so I get 3x. Combine the numbers, so I get 6. Subtract 6. x is equal to 5. So now we figured out what our variable is, being 5. So I'll plug that in there. So that's 10, that'll be 20. And then 5 minus 4, which is 1. Is that okay? So, any others on number 3? All right with that. Number 4, anything you want to see there? Okay. Number 5. Or 6. Yeah.
C.
6 on number C. Number 6, letter C. Is that what I was trying to say? All right. All right, that's ABC. Okay. And they told us that AB is 3x plus 12. And they also told us that AC is 90. Find x. Oh. If this is the midpoint, that means this also has to be 3x plus 12 because it would give you equivalent amounts by definition midpoint, which means you could say 6x plus 24 is equal to 90. Subtract 24, 70, 66. So x is equal to 11. And then we want to know, find x. We did. So all I did is I just combined those together to get 6x plus 24 and set it equal to the 90 that they told us. Yeah.
Can you do number
5, yeah. MNOP. Then N is the midpoint of MP. Wait, come on. N, bless you. N is the midpoint, so I'm going to color this in. N is the midpoint to MP. So this and this, even though it's not drawn to scale, these are equal in size. I know I didn't draw it to scale, but let's just pretend. Okay? And O is the midpoint of NP. And then we also know that this here and this here are equal lengths. They told us that the whole distance, M to P, is 20. Oh, okay. So, being that this distance here and this distance here, even though it's not drawn to scale, are equal, so that would make those both 10 and 10. And then being that the O is the midpoint here, so that would give me 5 and 5. And I think I answered the question, I think. All right? Cool. Yeah.
number 6, letter D.
6D. 6D is our ABC still. AB is x squared plus 2x. And BX, or BC, is equal to this. They want us to find x. They have told us that B is the midpoint. So if B is the midpoint, that means the segment on the left is equal to the segment on the right. So algebraically, I'm going to set each of these equal to each other. So if I subtract x squared from both sides, they cancel out nicely for us. And then if I add 3x, reduce here, that gives me 5x minus 3 is equal to 8. We add 3 to both sides. 5x equals 11. So x equals 11 over 5, or 10 and 1/5. And were we just finding x? Yep. There we go. Anything else on that page up to number 7?
Wait, so I just want to clarify really fast for C. So that's, so you know the other side is also 3x plus 12 because it's only giving you measure AB.
Yeah, well, they told you in the directions, it says assume B is the midpoint for AC. So if they gave us one segment of AB, then the other segment has to be identical because by definition of midpoint. So whatever it was, it could have been smiley face, and you'd have 2 smiley faces. But they happen to give you 3x plus 12. So 3x plus 12 and 3x plus 12 are the 2 segment lengths. Cool. We're good up through 7? Anything else on the rest of that? 8 through 17. Some of the factoring might have jumped right out at you. Another factoring might have been skipped over because you kind of forgot it. Or you looked at the answer going, oh yeah, I can see it being, 2/3 and 7/5. I'm just kidding. I don't know if that was one of the answers, but I'm just saying. Are we good on, everyone feel comfortable with that? So definition of a midpoint means that if you knew if you knew the midpoint, then the part on either side have to be equal. Okay? Even if they're completely different things. So on this one, we were able to say this is the midpoint. So I set these completely opposite things equal to each other. Because of definition of midpoint, they have to be equal. Is it possible that we could get a goofy answer that would be a negative length? And what would happen if I were to say, hey, what is the length of AB or BC? You'd have to take 11/5 and plug it back into X on either of the 2 above. Is it possible, though, you could find an answer saying, oh, okay, I found X. If you plug it back in, the negative answer comes out for a length? The answer is yes. Does anyone know what kind of answer that would be called? It's called an extraneous solution. You can't have a negative length. Okay. So that's something that we will talk about, as the class progresses a little bit more. CP accelerated geometry. We all have to pick something called a goal that we'll kind of look at for the whole year. And we have chosen as a group to go with extraneous solutions. And that's where once you solve it, you plug it back in, it doesn't mathematically make sense. So it would either give you like a negative length, or it would give you like a negative under the square root sign or something like that. All right? But don't panic. You're like, dude, I don't get this. By the end of the year, you'll be like, solid. I got it. Cool. May I move to the next page? Now I just asked you all to start that. You didn't have to get it done, but let's look at it and see if we can work through it a little bit. Problem number 1. Should we do it? Want me to do it? All right. So this is from section 1.3, right? I got a song stuck in my head, sorry. Yeah, do you want it stuck in your head too? All Star by Smash Mouth. Not sure why, it's there. Alright. So they want us to identify acute, right, obtuse, or straight. So CBD is acute. How do I know it's acute? Well, 90 is a right angle, and it's definitely smaller than that right angle. And then EBC, so EBC is a right angle. How do you know? Because there's the right angle symbol in there. EBF. EBF. I think you'd be okay to say it's acute, and this is why. Being that ABC is a straight angle, that means if that's 90, this has to be 90 by definition. And then I have a part of a 90-degree angle, which would have to be acute. ABC is a straight angle. ABD. Well, being that this is a 90 here, and that's more than that, that has to give us an obtuse. And then FBC. This one right here. Being that's more than 90, that has to be obtuse. Yes, I'm drawing in that dotted pink. Is that right? Find the limits of each angle. C, B, D. CBD, as far as the limits go, CBD is right here. So it has to be between, rounded bracket, 0. Woo! Excuse me. That came from the toes. All right, CBD has to be between 0 and 90 degrees. I can represent it with rounded brackets, meaning I approach it, and those are limits. Don't make them square brackets because that means they're equal. Yeah?
Do you have to use brackets? Or can you use the
Greater than less than, it's totally fine. Yeah. CBF. CBF. So this one. So we use rounded brackets. Again, you can use greater than less than. I'd say it goes from 90 to 180 using rounded brackets so it doesn't equal it. Cool? So let's talk about something real quick that, just so we're on guard. Obviously, this morning we had a shelter-in-place drill. That's in case something off campus is taking place that might promote danger, so we're trying to keep people out of the building, which, you know, that's good. We want to protect you guys. You know, a lockdown would be there's a threat in one of our buildings, meaning we are, you know, trying to stay away from that door, away from those windows. We're closing those blinds. And hopefully the good guys get here before the bad guys. Okay? But I just want to make this very clear to all of you. If someone comes through that door and they're going to incorporate harm, I will do everything in my power to stop that person. And I have been trained in martial arts. So I have no problem throwing. I just don't need somebody saying, "Ooh, you're hurting him or her." Got it? Yeah. If they trip, we laugh. And then it hurts their feelings, and that's even better. So from 2nd through 7th grade, we had a former Green Beret who lived down the street from us growing up. And he said, I want to teach the kids on the street judo. And we learned judo. I did not belted because he wasn't a master sensei. But boy, I'll tell you what, there were things that he taught us that pretty impressive. So that's my game plan. If something happens, if something worse takes place, I grab the smallest one of you and use you as a kid. Deal?
Deal.
So, and no one's going to say, oh, stop. No, you're going to hurt him. Yeah. you ever hear of the? There was a judo competition taking place in Los Angeles at UCLA, University of California, Los Angeles. They had college judo teams from around the United States, and the female judo team from Florida State was in a van, and a guy tried to carjack them, and the sheriff said he was twisted up like a pretzel until we. That's how they had him held until we got there. I thought that was classic. Oh, I'm gonna carjack this van full of women. Yeah, it's the judo team. I think that's beautiful justice. Did they hurt him? I hope they did. I'm sorry, I shouldn't speak that way. That's bad of me. All right, back to our story. Number 2, how are we feeling with the limits? I'm using rounded brackets. Rounded brackets are fine if you use greater than and less than. That's also fine. I understand both. Cool? If we ever tell you, hey, put it in this form, and you don't remember what that form is, I'll give you a heads up saying, hey, it's greater than, less than, or it's the brackets. Yep.
So for 2A,
2A.
it would be
Between 90 and 0 and 90 degrees. Because it's a right angle. Or it's an acute angle, excuse me.
so it would be I'm just gonna do it from left to right. So it would be 0 degrees is less than angle CBD, which is less than 90 degrees.
Like that, yep. The reason I didn't like that is this
Yeah.
starts looking like that.
Uh,
You know, like, why do I have a less than sign? Anything else on that page that you would like me to work out? It doesn't make sense. 7. Angle B is obtuse. Measure of angle B is that. Find the limits of x. Okay. So if it's obtuse, what does that mean?
It's greater than 90, less than 180.
Yeah, it's going between 0 and 180 degrees. Everyone with me? Sorry, I'm being lovely, snorting snot. So measure of angle B is 1/3 x plus 30. How should we start it? This is a pre-calc question. I like it a lot. How do I start it? How many problems do I set up here? Yeah, 2. Why 2? There it is. So it has to be less than 180 and greater than 90. So I could go 1/3 x plus 30 is greater than 90, and I could go 1/3 x plus 30 is less than 180. Seem okay so far? Let's change colors. Black's boring. 1/3 x is greater than 60. X is greater than 180. 1/3 x is less than 150. Multiply by 3. X is less than 450. So if we were to put these back together, we could do this. 180 is less than x, which is less than 450. Pick the smaller of the limits, flip the whole thing over so the signs go in accordance with it. Everybody okay? Yeah.
How do you do number 3?
Number 3? Oh no, I haven't done it yet, but I will. Number 3. If EBF is 20 degrees and BD bisects EBC, find the measure of each angle. Okay. So I think I'm going to use okay. ABC. B, C, and D, E, F. All right, so if they tell us EBF is 20 degrees, is that what it told us? You can see that, okay. Squint if you can't. Go to the pinpoint on your fingers like that. And BD bisects EBC. So this is the bisector of this. So that means that this angle here and this angle here are equal to each other. Let's see if we can find the remainder. Okay. So with our diagram, if we know that that bisects, that this means that this angle here is 45 degrees and this is 45 degrees by definition of bisector. Okay, if we cut a 90-degree angle in half. Other things that you would know, that this angle would have to be 70 degrees because if this is a right angle here, that means that this is a right angle here in which we have 20 degrees already we're talking about. And so from there, we should be able to find every angle available. So they tell us CBD. Well, we have CBD, that's 45. And then we need CBF. CBF is here. So it's 45, 45, and 20. So that's 90 plus 20. So this angle here is like 110 degrees. 90 plus 20, right? And then ABF. ABF. So this angle here, we just found it to be in 70. And then FBD. FBD is this angle and this angle put together. Well, this one's 45, that one's 20. So this angle has to be 65 degrees. Does that make sense how I just went through that? Cool. Yeah.
Can you go back to what you did for
Number 7. Is that number 7?
Yeah.
Okay. Does that make sense? Are you okay? Okay. We're off the first page. Is that all right? Second page. Happy to do any of those. Or do you want me to just start with number 9 and go on? 9 and go on? All right. ABC. BD bisects ABC. So things that we know that this angle and this angle have to be equal to each other by definition of bisector. So if they told us ABD is 10x plus 5, ABD is 10x minus 5, is that what I said? Plus 5, excuse me. And then they told us that CBD is 40x minus 40. They would like us to find x and ABC. So they want to find the whole angle. So what can you tell me about 10x plus 5 and 40x minus 40? They're what? They're equal. Okay, by definition of bisector. Okay, so I get 10x plus 5 is equal to 40x minus 40. Subtract 10, I get 30x over here. Add 40, so I get 45 over here. So x equals 45 over 30, which reduces to 15 goes into both, so 3 halves. Is that all right? So we found x. In order to find any of the angles, I just need to plug it in. They should be the same. So I get 10 times 3 over 2 plus 5. Well, that's 5. That's 15 plus 5. So 20 degrees. And that should also be 20 degrees if we plug it in, which it is because 40 times 3 over 2 is 60. And then 60 minus 40 is 20. Do the exact same thing for letter B. They tell you ABD is 6x plus 2 and ABC. The only difference on the next one, the entire angle they tell us is 11x plus 7. They tell us that. ABC and then ABD. Okay, so ABD is 6x plus 2. So the whole angle is that. And then if I do ABD twice, so that's 6x plus 2, 6x plus 2, that's 12x plus 4. Subtract 11x. Why can I say this? What did I do to get right here? Each angle was 6x plus 2. Why did I know that? Because we have something that bisected it. Cut it in half. So I just took the 6x plus 2, added 6x plus 2 to get 12x plus 4. Subtract 11x, so that's that. Subtract that, I get a 3. So our whole angle is 33 plus 7 is 39 degrees. So, B. So 39 degrees is the whole angle, and then the two half angles are CBD. So I need to do half of that. So half of this is going to be 18.5 degrees is our angle CBD. Yeah.
How did you get x equals 3?
I subtracted 11x, so that gave me an x,
Oh,
and I
never mind.
subtracted
It's
4.
plus 7. I wrote minus 7.
Yeah.
33 plus 7 is 40.
It is. Thank you. So that's 40. So that's 20. Thank you. Darn arithmetic. It's getting to me these days. Yeah.
How did you get 12x plus 4?
Because we know that the two smaller angles, they told us we have a bisector. So this angle and this angle have to be the same. So we knew one of the angles was 6x plus 2. So the other angle also had to be 6x plus 2.
Then why did you put the 11x plus 7?
They told us the whole angle is 11x plus 7. So then they told us that this was 6x plus 2, so that means this also has to be 6x plus 2.
Okay.
Yeah.
And also, how did you get from x equals 3 to 40 degrees?
40? I just took this and I plugged it in for x, so that
Oh,
becomes 33 plus 7, which is 40. So the whole angle is 40, and then each of these angles, not using those, is going to be 20, 20. 10, 11, do? All right. I'm sorry I'm not feeling good today. Jeez, I want to feel better. WYZ. X. All right. WXY. WXY, they tell us is 2x minus 10. And then YXZ, they tell us is 1/2 x plus 21. Okay, and they tell us WXZ is 68, so the whole thing is 68 degrees. And then, okay, find x and determine if xy. So they want us to tell them once we do our math if this bisects our angle. We don't know that yet, but we know that we have two angles, one being 2x minus 10 and the other one being 1/2 x plus 21. They will have to equal 68 degrees. Is that okay? Just for sake of time, let's subtract the 10, so combine these together, so that gives me 11. And then let's move the 11 over. Notice I'm not combining anything yet. So subtract 11, so that's 57. Anyone know what I'm going to do now? I could combine the x's, but I'm not quite sure what 2x plus 1/2 x is equal to because I forget those things. So what's a math thing I could do? Yeah. Good.
Multiplying
Yeah, if you multiply everything by 2, and this is good practice, we're clearing our denominator. That's 2 over 1, and that's 2. So that's going to give me 4x plus x equals 2 times 57, which is 114. So that's 5x equals 114. So x is equal to 114 over 5. So that's what x is equal to. We could leave it as 114 over 5, which is an improper fraction. How did we know if these were equal to each other? They have to bisect. That's what we're trying to find. So I'm going to take 2x minus 10, and I want to know if that's equal to 1/2 x plus 21. What am I plugging in for x? 114 over 5. If this becomes a true statement, then we can go ahead and make the conclusion. So that's 228 over 5 minus 10. So that's 228 over 5 minus 50 over 5. And we want to know if that is equal to 114 over 10 plus 21, which that's 114 over 10 plus 210 over 10. If I were to add that together, I'm going to get 324 over 10, which is 32.4. If I were to add these together, 228 minus 50, help me out. What's 228 minus 50? How much? 180, 178. And 178 over 5 is equal to what? 32.4.
No, 324.
What is it?
324 over 5.
324 over. 178 divided by 5 is what?
Well, hold on. You're at for after the equal sign. You're adding the 210 and the 114.
No, that we just want to know if those are equal. What's 178 over 5? Somebody? 32.4? And what is it? 35.6. Thank you. Is 35.6 degrees the same as 32.4 degrees? No. Does that green line bisect the blue? It cuts it, but it doesn't cut in half. Number 12. We okay there? I think we can do it. So find so number 1, measure of angle 1. Well, we know that we have 25 and 90. So that's 90 minus 25 is 65 degrees for angle 1. Measure of angle 2 is 65. Shoot. I gotta blow my nose. I'm sorry. All right, so if you want to find this angle, it's going to be 25 plus 90. If you have a calculator, it'll go a lot faster. That's 115, right? 115 minus 180 gets me this. which is 65 degrees, I think. Cool. So that's angle 1, angle 2. We then want to figure out this angle here. So I could do, oh, I know that, let's see, that's 90. That's 65. How am I going to find that one? Oh, this has to be a 90-degree angle as well because of vertical angles with this. So 65, that's going to be 25 degrees. And then angle 3, which is here. So this has to be 65 degrees as well because 65 plus 25 gives us a 90. ABE is this whole angle, so just subtract 180 minus 25. So that's 155. And guys and girls, I will tell you that the construction there we don't have to worry about. Okay? And I will give you this worksheet, which can be used as a review. You might have a small construction on the test. It will not be doing the construction of 3 different sections. Now here's the deal. If you want to hand those worksheets in to me today, you can, or if you want to study them, you can hand them in tomorrow for no loss of points. So it's your choice. If you want to hand it in today, then let's have you make sure to staple the name on it, put it right over by that pink bag. And then this worksheet coming out to you all, we might have just a couple of minutes tomorrow to go over it.
So we